Hi class, I wanted to do a little synthesis and then maybe give you a little accompaniment to go with my worksheet that I gave you to do the Friday before. It had a lot of stuff to do, and I'm going to post all that stuff. I just haven't gotten around to posting it, but I said I'd give a little video accompaniment because a lot of people didn't come to class. And a student had a really good idea, and I want to try it out here. I'm going to try it out really raw, okay? Because some people didn't like my little cycle carnival situation that I was using to do resonance forms. So in my last video boost, I suggested a synthesis, okay? And I said, let's make this. And for people who really struggle with synthesis, this is the best place to do synthesis because aromatic synthesis is very logical. So it'll start kind of clicking together with you, I think, on this topic. And you can do them forward. A lot of people do them forward and they don't have to do the retro thing. So say I wanted to make this from this and methane, and I'm going to keep incorporating things that we've learned so that you eventually learn all your reactions. Keep working on it. Don't just give up. You can learn this and you can get good. People are getting a lot better. I saw a big improvement on the last test. Whether you feel that or not, it's true. A few people, you need a little extra help. You've got to come in for some extra help. Okay, so what would I do here? Well, what I want to do is get a nitrogen on here. I'd want to put these methyl groups on the nitrogen, and I'd want to put the bromine on. And so it suggests that I've got to do some chemistry on the aromatic ring, which means I either have to do some kind of nucleophilic chemistry or I have to do electrophilic. Now this would be electrophilic and this would be nucleophilic, okay? Now, we have very raw starting materials. So what I would do first, and there's a really good reason for this, I would put the NH2 group on first. And the reason I put the NH2 group on first is it's an activating group, whereas a bromine is a deactivating group. And a bromine isn't really going to help anything. So I'm going to put the NH2 on first. And, oh no, wait a minute. I got to brominate first. Take that back. So the first thing I would have to do, right, to get the NH2 group on is I have to have a halogen on the ring. So let's add bromine. You know how I love bromine. Iron, tribromide. Think about this, what I'm doing here. Every exercise you see is great. Your textbook in Chapter 16 and Chapter 18 has lots of problems like these. You don't have to do the really elaborate ones. I kind of give you choices through the whole book, but you don't have to do the really elaborate. Now this is an EAS reaction, so I'm getting the ring activated. Remember, when you have a hydrocarbon and it has no functional groups on it, you have to put a halogen on. That's almost, you have to know your halogenation reactions. You must know them. That's why I gave you that toolbox kit. The toolbox is also up on the web, so you can use it. All right, so then I could put the NH2 group in by adding Na, NH2, and ammonia. And again, these are very harsh conditions, and this is not a normal nucleophilic reaction because the ring is not activated. This is the harsher and stranger elimination addition. I'm just showing you how you could get an NH2 group onto the ring. So I've got the NH2 group onto the ring. Now, I want to talk to you about a few little weird problems with electrophilic aromatic substitution, right? I have to put a bromine down here, all right? And that's going to be a little problematic because this group is nucleophilic. And if I put a Lewis acid catalyst in with that nucleophilic agent, I'm going to form a Lewis acid-based catalyst that has a positive charge. Try it. This is why I think I gave you this information at the beginning, but I said you can't do Friedel-Crafts if you have these donating groups. Okay, so what I'm going to do first, there's no real reason for it except I want to bulk this up a little bit. But I could put the bromine on now if I want or later, but I think what I don't want to get involved with nucleophiles with that bromine on there. So what I'm going to do is I'm going to just put the two methyl groups on, which is old chemistry. How would we do that? Okay, this is how we would do it. Okay, so what we would do is we would want to take these hydrogens off. So basically we want to make the nitrogen negative, which is very natural, and we'd want to make the carbon positive. So how would I make the nitrogen negative? This is the same as the way you make an oxygen negative. You add a strong base. So for example, I could add sodium hydride. If I did, I would get this anion. And this should start to make, it's a resonance stabilized anion, but it's still reactive. And then what I'd want to do is react it with this bromide, like so. What reaction is that? SN2. SN2 is the backbone of synthetic chemistry. You have to know it, okay? If you don't know it, you've got troubles. Okay. What would you do? You would just do this again. Now, why do you have to do it twice? It's really hard to form a dianion. So I would add 1 NaH, 2 CH3Br. If you're getting good at your synthesis, you know how to activate that alkane. Okay? How do you activate the alkane? You have to take methane. Now, this is ridiculous. Nobody really does this. But you would have to take methane and add Br2 and light. But I just want you to keep in mind, we're learning strategies here, a logic, a way of playing a game, okay? It's a game, all right? Okay, so once we do this, we're almost good to go. And what I want to show you, I want to reiterate this point about I want to make a little point about this, but first, just come in the kitchen because I'm going to stir my risotto. They can look at my risotto. Okay. I'm making risotto, and I don't want to burn it. So this will give you a minute to think. I'm ruining my risotto. My kitchen's a mess. So I've never made risotto before. You can take a look at it, see what you think. My sister taught me how to make this over the weekend. So I'm working on this. And I put some chicken broth. This is like organic synthesis, right? Okay, so I just don't want to burn it. I'm almost done. Okay, the chicken's going in there. All right, we're done with that. All right, I thought that would give you a little break from my babbling. Okay, so now you know. Now you see I have a kitchen in my house. All right. So anyway, this is. I wanted to say a little bit about this. What's my time right now?
It's 7 minutes.
7 minutes. Okay. So. There's a couple things you should know about this. First of all, this is one of the most activating groups, okay? Very activating to EAS, okay? Why? Because it has those electron donating groups. And if you look on the list of groups, the ones with the lone pairs are the most activating. O and N, they're fantastic. And they really activate the ring. And they activate the ring so much that some reagents don't need catalysts, okay? So if I want to do a bromination on this, all I need to do is add Br2. I do not need to add a catalyst. Now, why might I be a little leery of adding a catalyst? Because this is what would happen with the catalyst. These are things you should think about. This would grab the catalyst. And in grabbing the catalyst, what happens to its charge? You must think about this. The book doesn't cover this. They kind of avoid this in problems. But it's something to think about. It's not always a big issue, but it can happen. So if this thing grabs this catalyst, you form a Lewis acid-based catalyst, this has a plus charge. Is this an activating group anymore if it's lost its lone pair? No, okay? So I would personally prefer to do this reaction on this very activated nitrogen group without a catalyst. And think about this group. Now, what is this group? This is an activator, OP director. We know everything with a lone pair is OP director. So that means it's going to direct the group in here, here, and here. We tend to get more para substitution because there's a little bit of a steric problem at the ortho position. But we'd actually get two products here, no doubt. We would get some. So your syntheses are not necessarily going to be 100%. You would get some of this, and you'd get some of the para.